Chris, thanks for your question. It looks like today we are going to be solving a system of equations in two variables using linear combinations. So as you can see over here, this is a four-step process. So we're just going to go down the list one at a time and check off our steps. And when we get to step number 4, we know our problem is complete. So the first step in this process is to multiply one equation by a constant to create opposite terms. What I mean by that is we're going to pick an equation, which one you pick doesn't matter, but we're going to multiply that equation by something to make opposite terms in these equations. All of them don't have to be opposites. We just want one of them that is above and below each other to be opposites, because our goal is actually to eliminate one of the variables. So I'm going to choose the second equation just arbitrarily, and I'm going to be multiplying by some t so that this becomes the opposite of this. I don't know what that t is, but what I could say is that negative 2t is equal to 3, and I can solve for t, so t becomes negative 3 halves. If you do it this way, the important thing to remember is you don't actually want to multiply by 3 halves. You want to multiply by the opposite of 3 halves. So we're going to use the same value, but the opposite sign. So rewriting this down here, I have 3x plus 5y is equal to negative 16. And below it, I have t is equal to 3 halves, the opposite of negative 3 halves, times negative 2x plus 6y is equal to negative 36. I can then distribute this through this equation and simplify. So 3x plus 5y is equal to negative 16. And then this, of course, becomes the opposite of 3. That was our original goal. So it becomes negative 3x. 3 times 6 is 18. 18 divided by 2 is 9. So 9y is equal. And don't forget to distribute it through this constant on the right-hand side too. That's a part of the equation too. So 3 halves times negative 36 is negative 54. And our first step is now complete because we have opposite terms. Second step is we're going to add the new equations together to eliminate one of the variables. We're going to literally create an addition problem, and we're just going to add down. So these are opposites, so this just becomes 0. 5y plus 9y is 14y, and negative 16 minus 54 is negative 70. So part 2 is done. Part 3 is we are going to solve for the remaining variable. The only variable left now is y. So we can solve for y. Y is equal to negative 70 over 14. So negative 5. Negative 70. I've got to pull out my handy dandy calculator on this one. Yep, negative 5. So we're left with a constant value for y over here. So we can now take that and move on to step 4, which is we can put that value for y in one of our original equations. Doesn't matter which one. And we can reduce it to one variable again and solve for the other variable. So I guess I'll pick the first one just arbitrarily. So I have 3x plus 5 times negative 5 is equal to negative 16. Or we can simplify this. 3x minus 25 is equal to negative 16. So this turns into 3x negative 16 plus 25 is 9. Solving for x here, we have x is equal to 3. So our values, our solutions for x and y in these particular equations are y equals negative 5 and x equals negative 3. And that is your final answer for this problem since we've completed step number 4. So thank you very much for your question. I hope this has been helpful, and I look forward to answering more of your questions using SnapMath in the future.